Motors, what are they? How do they work? And why are they trending right now? Stick around as I give you an engineer's perspective of what motors are and how they work. Hey everyone, I'm Mr. Sanga, your average engineer, and to start this off, I'm gonna give you a simple definition. Now, motors or electric motors are electrical machines that convert electricity to mechanical energy. By understanding how motors work, you can understand about magnets, electromagnets, and electricity in general. This is because electric motors use magnets to generate motion by using the simple principle of magnets, which is opposites attract and likes repel. You can create an electromagnet at home by wrapping a coil of wire around a nail 100 times and connecting it to a battery. This in turn generates the nail to become a magnet, not a permanent magnet, but an electromagnet powered by electricity. We have a DC motor and an alternating current motor. And they are basically the same thing, but different parts are involved in each motor. A simple motor has 6 parts, which is the stator, the rotor, the commutator, the brushes, the axle, and the DC power supply. Now, DC motors are mostly the ones that have these same power supplies, and AC motors have more parts, which I'll explain in the video. But let's dive into how DC motors operate. With that, I'm going to use SolidWorks. I designed a simple DC motor using SolidWorks to explain how motors operate. Okay, let's dive into SolidWorks to explain how a simple DC motor works. And in this design, I'll put the link in the description, or rather in the comments, to if you want to learn how to design this using SolidWorks. So we have the stator. The stator composes of magnets, which do not move. They're stuck in place by the housing components. Since the magnets are stuck in place, what actually moves is the rotor. And the rotor is composed of a lot of copper coils that are wrapped around it. So basically how a DC motor works is that electricity will run through these copper coils and they will create an electromagnetic field. This electromagnetic field is temporal and it interacts with the permanent magnetic field. Now we know that a magnet, or rather magnetic fields, have north and south poles. So the north poles will be attracted to the south poles of the permanent magnet, and the north poles will be repelled by the north poles of the permanent magnet. So because of the constant repelling and attraction between the temporal magnetic field and the permanent magnetic field, this will in turn cause the rotor to rotate. And that's how DC motors work. Okay, so now entering into AC motors. AC motors and DC motors are the same, except AC motors use an alternating current to power the motor. Now, an alternating current is simply a current that moves from 0 to maximum and then back to 0 at a high rate. AC motors usually depend on the flipping of the magnet and the electromagnetism to produce mechanical power. Because AC motors use alternating current, the coil around the rotor is different compared to DC motors. Another difference between AC motors and DC motors is that DC motors use a battery supply to obtain the electric current, while AC motors use what is called a squirrel cage. Not that type of squirrel cage. A squirrel cage in an AC motor is a set of bars that are connected to 2 rings, one connected at the end of another. Because of its design, it's considered a squirrel cage because it's similar to cages that are used to capture squirrels. When the squirrel cage rotor rotates inside the stator, AC current is then sent to the stator, which creates an electromagnetic field. This electromagnetic field then encourages the continuous rotation of the rotor. The bars in the squirrel cages are conductors, so they respond to the flipping of the stator pole. And that's how AC motors work. Now, AC motors are preferred for their large power output and efficiency, while DC motors are preferred for their speed and output range. AC motors are also available in single, 3 or 2 phase, while DC motors only have one phase. But overall, AC motors are considered more powerful than DC motors. Electric motors are an important factor into our life, and due to countries going for a green and stable energy, electric motors are here to stay. And overall, as the years go by, we shall see electric motors improve and used in industries such as agriculture, robotics, and even in your home. Thanks for watching. If you like this video, click like, and if you want to watch more, click subscribe. I really hope to see you in our next video. Have a great day and enjoy your week.